Good afternoon, class. We are looking at chapter 4, application of derivatives, section 4.4, optimization problems. So we've looked at maximum and minimum values, how derivatives affect the shape of a graph. Now we're going to look at optimization problems. So we have differentiation formulas from the basic definition to power rule, exponential rules, trigonometric functions, product, quotient rule, chain rule, and so on. The concept of dy versus delta y. Dy is the change in y along the curve, delta y along the tangent line, and finding linearization, which means find the tangent line using the point slope y minus y1 equals m times x minus x of 1. And you recall, as far as the max and mean, the local or relative extrema versus local or relative mean and max. Over here, we have a local mean, local max, local mean, local max. It happens in some open interval. As far as absolute or global, minimum versus maximum. So we have local mean, local max, local mean. This one is also absolute max. Local max, local mean, local max. This happened to be an absolute max. Now, to find critical points, find f prime, set it equal to 0, and where it fails to exist, does not exist. So these are the 3 steps. Find f prime, set equal to 0, does not exist. Also, we have what's called extreme value theorem or closed interval method. If you happen to have a function which is continuous in a closed interval, it must attain both absolute max as well as absolute mean. Methodology: find all the critical points, evaluate the function at the end points A and B as well as the critical points. The largest value is the absolute max, the smallest value is the absolute. The summary of a curve sketching, as you know, a function is increasing when f prime is positive, decreasing when it's negative. A critical point where f prime is 0 doesn't exist. A relative extremum happens at the bottom or the top of an interval. A function is concave up where f double prime is positive and concave down when it's negative. Concave up can hold water, and f prime is increasing. Concave down cannot hold water, and f prime is decreasing. If the change occurs at the point that where the change occurs, the concavity changes from concave down to concave up or vice versa, that's the point of IP, short for inflection point. So this is the synopsis of what we have done, and now the new stuff, 4.4 optimization problems. Optimization problem is the problem of finding the best solution from all feasible solutions. In other words, find a solution in the feasible region which has the minimum or maximum value of the objective function. So these are examples of optimization. We want to maximize profit, minimize cost, maximize area enclosed, etc. So we have what's called the first derivative test for absolute extreme value. If we happen to have a critical number of a continuous function, f prime is positive for all x less than c, and f prime is negative for all x larger than c, then f of c is the absolute max of the function. Otherwise, it becomes the absolute mean. So in short, what it is saying, the first derivative test dt for absolute extremum, a local extremum is an absolute one if it's the one and only extremum. In other words, when we do the sine graph, it tells us whether we are dealing with a local max or local mean. If there is happen to be only one, that is not only local, it is also an absolute. max or mean. The second derivative test for absolute extreme on an interval, if there is exactly one critical number, let f be continuous on interval of a to b, with only one critical number c in the interval. If f prime is 0 or f double prime, and f double prime is positive, then f of c is the absolute minimum of function f on the open interval of a to b. If f prime is 0 and f double prime is negative, then f of c is the absolute maximum on the open interval. So in short, same situation with the first derivative test. We have only one critical point. Then if we plug it into f double prime and it's positive, means what? It's concave up, so it gives you the absolute minimum. If it's negative, it means concave down, and it gives you the absolute maximum, and that's the idea. So here's an example that we are going to get started. A farmer has 2,400 feet of fencing and wants to fence up a rectangular field that borders a straight river. He needs no fence along the river. What are the dimensions of the field that has the largest area? Well, if we just wanted to make something up, we would go with different dimensions. For example, 100 times 2,200, 700 times 1,000, so on and so forth. In order to cover this constraint, if you. But if we want to do it properly using a mathematical process, we are saying we don't know the width and the length. So if this is x, this is x, this is y, then we want to maximize the area. So the objective is to maximize the area, which is x times y. But what is the constraint? We have 2,400 feet of fencing, so we have normally 2x plus 2y. This side doesn't need it, so just 2x plus 1y. 2x plus y equals 2,400 feet of fencing. That's called the constraint. So we want to maximize the area. We have two variables. We're going to use the constraint to solve for one of the variables, in this case, y. We are going to replace the y with 2,400 minus 2x. Now, it's important to know when we look at this one, x is between 0 and 1,200. Why is that? First of all, x represents dimensions, must be positive. Secondly, if you set this parenthesis equal to 0, x becomes 1,200, which means if you choose it to be 1,200 becomes 0. If you choose it to be larger than 1,200 becomes negative. Area can't be negative. So therefore, you have an open interval of 0 to 1,200. We take a derivative. A prime is 2,400 minus 4x. To set it equal to 0, x becomes 600. We can do both ways. We can do the first and the second derivative test. I'm going to do both. The first derivative test, at 600, a prime is 0. To the left of 600, the easy number, a TP, test point. For example, 0. Okay. Even for a test, you can pick 0, but 1 or any other number, okay, or 10 or 100. To the right of 600, let's say 700. So if you plug it into a prime, 100 makes this positive, 2,400 minus 400. And if you put 700, minus 4 times 700 is minus 2800, makes it negative. Now, arrow up, increasing, arrow up, decreasing, right? Positive increasing, negative decreasing. So up and down, this makes 600 location of a local max, local max. Why is this absolute? Because this is the only critical point. This is an open interval, and this is the only critical point. However, if you go with the second derivative and a double prime becomes negative 4, means concave down, right? The meaning of negative, and the maximum. So normally the second derivative test is easier. So the maximum occurs at x equals 600. Now you want the dimensions, put it into this equation to find the missing y, and you put it into this equation to find the area. So the y becomes 1200 feet, and the area is the product of 600 and 1200, and that's 720,000 square feet. So we have a we want to find two numbers whose sum is 80 and whose product is a maximum. Let the numbers be x and y. The objective is to maximize their product. So x, y, with the restriction that the sum is 80. So this means the maximum is their p is x times y. Let p represent the product. And here's the restriction. So the constraint is that they add up to 80, x and y. They add up to 80. We do the same thing as before. We solve for y, 80 minus x, and we put it here because this is a function of two variables. Now becomes a function of one variable. And again, I hope you see that because we want to maximize, we hope to avoid negative numbers as well as 0. That's why x is between 0 and 80. If you set this one equal to 0, x becomes 0. If you set this one equal to 0, x becomes 80. And if you choose x to be larger than 80, this becomes negative, okay? So their product becomes negative. And since we are maximizing, we want to avoid negative numbers as well as zeros. Therefore, we are going to take the derivative. P prime is 80 minus 2x. When we set it equal to 0, x is 40. This is the only critical point. We have the open interval of 0 to 80 instead of the first. I'm going to do the second derivative test. So p double prime is negative 2. A negative value means concave down, and it means maximum. So maximum occurs when x is 40. If x is 40 and the sum is 80, both of them must be 40. And what about the product? The maximum product of 1600. A farmer with 240 feet of fencing wants to build an E-shaped enclosure besides a creek as seen in the diagram. Find the maximum area that can be enclosed. Well, the objective is to maximize the area. So let's give it dimensions. Let's call this x, let's call this y, and the whole thing is the area. So the maximum of a equals x times y is the objective. What is the constraint? We have 240 feet of fencing. I hope you realize this is x. So we have 1, 2, 3x. This is y. We don't need this side. So 3x plus y equals 240. We solve for y again. And we put it into this equation to make it a function of one variable. And again, why is it that x is between 0 and 80? We are dealing with area and dimensions. Dimensions must be positive, so x must be larger than 0. What about 80? If you set this one equal to 0, gives you x equals 80. So if you choose larger than 80, the parenthesis becomes negative, the area becomes negative, we can't have it. So in essence, we have the following open interval, and that's really the key. We take the derivative, and to do so, it's easier that we distribute. We get 240x minus 3x squared. This gives us 240, this gives us minus 6x. Setting it equal to 0 results in x being 40. So we have one critical point. We can do the first derivative, but it's easier to do the second derivative test. A double prime is negative 6. Negative means concave, down means maximum. So I hope you see why we learned this second derivative test. Of course, this is a constant. If it was involved with x, we have to plug in this value. We will look at those cases. So the critical point x equals 40 is the only critical point, and it's going to maximize. So not only it's going to be a local, it's going to be an absolute. So we are going to put the 40 here, 3 times 40. And that's 120 subtracted from 240 becomes 120. So we have all the dimensions. Their product is the area for the 800 square feet. A box with a square base and open top must have a volume of 32,000 cubic centimeter. Find the dimensions that minimizes the amount of material used. So let's remind everyone of a couple of pieces of information from geometry. So this is a rectangular solid. Here's the width, here's the length, here's the height. The volume is the product of the three. Surface area, that means if we were to gift wrap it, would be the area of each side, for example, this side times 2, and then add them up. So that's why we have 2 times the width times the length, that means the bottom and the top. Height times the length, height times the length, that means the back wall and the front wall. And height times the width. This is the height, this is the width, that means this side and the one here. That's why we have the 2. So that's for a rectangular solid. If it happened to be a cube, which means all sides are identical, the volume is s cubed, and the surface area, SA, surface area is one side, the area of one side times however many sides, so 6s squared. In this case, we have, we have a case where the bottom is square, okay, and the top is open. So if we were to find the dimensions that will minimize the amount of material, that means we want to minimize gift wrapping. The walls would be x times h, and there are 4 of them. They're all identical. The bottom is x squared. Normally there are 2 of them, so we have plus 2x squared, normally. However, the moment we see open top, that means the top is not there, so plus 1x squared. So the surface area we want to maximize is 4xh plus x squared. What is the constraint? We want this such that the volume must be 32,000 cubic centimeters. The volume is x times x times h. So x squared h is 32,000. That is the constraint. All of this so far has been algebra and geometry, and now we are in business. We are going to solve for h, which is 32,000 over x squared. and we put it into S in order to make S a function of one variable. So we are going to replace the H. And when we do that, as you can see, 4 times 32,000 is 128,000. This X goes away, this becomes X. We're going to bring this up and make it 128,000 x to the power minus 1. And X is positive because the only thing that we know is that dimensions must be positive. There's no other restrictions. So X is positive, or we are dealing with the following open interval of 0 to infinity. Sky is the limit. We can have any numbers. To differentiate, we are going to use this one. The product of these two makes it minus 128,000 x to the power minus 2 plus 2x. We are going to figure out the CPs, remember, critical points. And to do so, we are going to rewrite this as over x squared. We're going to drop this, right? We're going to take it down, make it positive x squared. And so what is the common denominator class? X squared. So this one doesn't change. 2x times x squared makes it 2x cubed with the. So this 2x is this 2x cubed divided by x. So S prime is 0 when the top is 0. So 2x cubed is 128,000 divided by 2, you get 64,000. And take a cube root and it becomes 40 centimeters. S prime doesn't exist if the bottom is 0, bottom is 0, x becomes 0, and it's not in the domain. So we have one critical point. Because we have an open interval and one critical point, whatever happens, it's not only local, it's also absolute, but we don't know if it's a local max or mean. So to prove that, we go with one of the methodologies, first or second derivative, and we are going to go with the second derivative test. So let's look at S prime here. Minus times minus makes it positive. The product of these two numbers, 256,000 x to the power minus 3 plus 2, that's S double prime. So we are taking the derivative of this expression. And now that x is involved, you have to plug in 40. And if you plug in, you get a positive value. I want to show you why we know that. Because if you plug in class, you don't even have to evaluate it. Here's what you get if you plug in. You get 256,000 divided by x cubed, 40 cubed plus 2. Now, please understand, you don't even have to evaluate it to know this is a positive value. Plus 2 makes it even more positive because we just want the sign. Of course, you can do the math. It's really not a big deal. It's just 40 cubed and you get 64,000. Okay, just so you know, and the answer is 4 and 2 becomes 6. But you don't even have to evaluate it to know it's positive. Because it's positive, then it's concave up and it gives you the minimum. So the minimum occurs when x is 40. Now go back here, figure out the surface area, figure out the volume, all of the above. So if I put this back here or here, it can give me the h, either this one or this one. Give me the h. So h is 32,000 divided by x squared divided by 40 squared, or 1600, which gives you 20. So we have the dimensions. We are done because that's all we wanted. But if we were interested in finding the surface area, we have to plug it into that. So h is 20, x is 40, and if you plug in, you get 4,800 centimeters squared. Find two numbers whose difference is 18 and whose product is a minimum. Well, we choose them to be x and y. The objective is to minimize their product x times y. And we know their difference, x minus y or y minus x makes no difference, is 18. The reason it makes no difference, ultimately you get two numbers, and if you change that to y minus x, then the order by which you find it may be different than the other person, but the two numbers are the same in different orders. Now, in order to have one variable here, x, we're going to solve for y, so y can go to the other side, 18 comes here, x minus 18 is y. Plug it into here, and it becomes x times x minus 18. And sky's the limit. I want to explain why the domain is all real numbers. It can be anything. Because what are we trying to achieve? We want to minimize the product. Is 0 good? Yes. Is negative good? That's even better. So because we want to minimize it, we don't care if the result would be negative 0. Okay. Therefore, it is an open interval of negative to positive infinity. Now, the reason we write it in this format, because it's easier to differentiate 2x minus 18, p prime of x. If we set this equal to 0, x becomes 9. So we have a open interval. We have one critical point. So this is not only local, it is also absolute. But is it absolute mean or mean or max? We don't know. We are going to do the second derivative test. Here's p prime. So p double prime makes it 2. 2 is a positive number, which makes it concave up, which means minimum. So minimum occurs when one of them is 9. So go to this formula, replace the x with 9. 9 minus y is 18, and y becomes negative 9. So the bottom line is one is positive, one is negative 9. What is the minimum product? Is negative 81. Let us enclose a rectangular area of 288 square feet and then divide it into 3 equal size pins with parallel sides. What dimensions will minimize the material needed? So we know the area, but we want to minimize the material. So to do so, let's say this is x, this is y. So we have 1, 2, 3, 4 x's, and we have 1 and 2 y. So 4x plus 2y is a p, the perimeter that we want to minimize. And the area is x times y, and is 288. That is the constraint. So in this equation, we are going to solve for one of the variables. More specifically, let's solve for y becomes 288 over x, and replace the y here with 288 over x. And this is 4x, this is 2 times 288, or 576 over x, or x to the power minus 1. And there is no restriction except dimensions must be positive. You have the open interval of 0 to infinity. To find the CP, we are going to differentiate this. This becomes 4 minus 576 x to the power minus 2. To solve this and everything, first let's rewrite it by putting this underneath, take a common denominator of x squared, this becomes 4x squared. And now a fraction is 0 when the top is 0. A fraction is undefined when the bottom is 0. The bottom is 0, x is 0. It's not part of the domain. Set the numerator equal to 0 to find all critical points. Four x squared is 576. Divided by 4 and you get 144. So x is plus minus 12 feet. We can only use the positive one because x represents a dimension. And so, is this going to maximize or minimize? We do the first or second derivative test. And it's easier to go with the second derivative test. Take a look at p prime. This gives you 0. This gives you minus 576 times minus 2, which is positive 1152x to the power of negative 3. That's p double prime. Or even 1152 over x cubed. Now, when I plug in 12, I don't even have to evaluate it. I know it's positive. Why is it positive? Because the top is a number which is positive. 12 cubed is a positive number. The ratio is positive. Therefore, it's concave up. It's concave up means minimum. So the minimum occurs when x is 12 feet. So what is y? X times y is 288. You use this formula, or you use y equals 288 over x, 24 feet. Those are the dimensions. 12 by 24. They didn't ask for the minimum value, but if you want to find the minimum fencing that you need, the minimum amount of material, 4 times 12 plus 2 times 24, they add up to 96 feet. Okay, so change this to 12. And this one to 24. And you get 96 feet of fencing or 96 feet of material. That's what you need. From a thin piece of cardboard, 8-inch by 8-inch, square corners are cut out so that the sides can be folded up to make a box. What dimensions will yield the box of maximum volume? What is the maximum? So in short, we have this one, which is 8 by 8. And we're going to cut out the squares. So what happens is that if this is 8 by 8, now we cut the x. Please understand this is 8 minus 2x because this whole thing was 8. And you fold it up. It becomes a box. The dimensions are 8 minus 2x, 8 minus 2x, and the height of x. So the objective is to maximize the volume, which is the length times the width times the height. And the constraint is that the length and the width are the same, 8 minus 2x, and the height is x, which means you replace it in this formula. So let's replace it. X times 8 minus 2x quantity squared. When you square this, you get 64 minus 2 times this one minus 32x, and then square this one, you get 4x squared. By the way, the reason x is between 0 and 4, because x represents dimension, so it must be positive. And why 4? Because if you have 8 and folded in half, it's 4. Or you can say 8 minus 2x is 0, x becomes 4. If you choose 4, becomes 0. So a number larger than 4 results in a negative. It can't be. Again, the dimension was that this is 8. So if you cut it in half, 4 and 4, there is no box. I want to make sure you this is extremely important. So the open interval of 0 to 4. Again, you can set this one equal to 0, x becomes 4, and you recognize that. You can look at this shape. So if I cut it in half, I don't have a box. So it has to be less than that. So the x must be less than half of it. So what is the volume we have to? So let's do this. So as I mentioned, 64 minus 32x plus 4x squared. So we have 64x minus 32x squared plus 4x cubed, and I'm going to put it in descending order by putting 4x cubed first, minus 32x squared second, and finally 64x. And I do that because I want to differentiate this, and I like to have it in descending order. 4 times 3, 12x squared, minus 32 times 2, minus 64x plus 64. Because I want to find the CPs and I need to set this equal to 0, first I'm going to factor the common factor of 4 out. Because this is 3, it's a prime number, it's x and 3, and then 16, it's the product of 1 and 16, 2 and 8, 4 and 4, and both of them must be negative or positive. Because this is negative, ends up having negative value. So there are two answers. This gives you x equals 4/3, right? Set it equal to 0. This gives you x equals 4. I want to make sure that you understand that. So this one, 3x equals 4. This one, x equals 4. So we have two answers. And you go back here, it can't be 4. Because if it's 4, there is no box, everybody. So you have an open interval with one critical point. Therefore, that must not only be a local pulse, but also an absolute. But absolute what? Minimum or maximum? If we don't know it yet, we have to do the first or the second derivative test. And we are going to do second derivative test. V double prime is 24x minus 64. Now we're going to plug in 4/3 instead of x to see what we get. We want to see if it's positive or negative. So we have 32 minus 64 minus 32, which makes it negative. Negative means concave down. Concave down, looking like that, meaning maximum. Concave down. So the maximum occurs when x is 4/3. So if x is 4/3, you put it into this one, 2 times 4/3 and subtract it from 8, and you get 16/3. So the dimensions are 4/3 by 16/3 by 16/3. This is the answer for dimensions. What is the maximum volume? Multiply. You get 1024 over 27, or 37 and 25 over 27 cubic inches. This is an exact answer, everybody. A stereo manufacturer determines that in order to sell X units of a new stereo, the price per unit in dollars must be P of X equals 1,000 minus X. The manufacturer also determines that the total cost of producing X units is given by C of X equals 3,000 plus 20X. Find the total revenue. Well, as you know, revenue by definition is the number of units times the price. So X is the number of units we're going to sell. P is the price of their product. So this times X. Profit by definition is revenue minus cost. So we are going to subtract the cost from the revenue. So this is minus 3000 minus 20x, and we can combine these two. If we put them in descending order, we get negative x squared plus 980x minus 3000. How many units must the company produce and sell in order to maximize profit? To maximize profit, we're going to go with calculus and take the derivative. P prime is negative 2x plus 980, set it equal to 0, and solve for x, the critical point x equals 490. Now, there's only one critical point. And as far as the domain for x class, domain for x, you could say 0 to infinity, because it's possible that we do 0 and we don't produce anything, okay? Which doesn't give us any profit to begin with. That's why in essence, you can treat it as an open interval. So it's better to go with P double prime, which makes it negative 2. Negative 2 means what? Concave down and maximum. So this means concave down. The maximum occurs at x equals 490. What is the maximum profit? Well, go to the profit function. Replace the x with 490. Do the math. And it gives you $237,100, which means the maximum profit is achieved when we produce 490 and we sell, and this is the profit. What price per unit must be charged in order to make this maximum profit? Here's the price. Here's the x. 1,000 minus x, 1,000 minus 490, which makes it $510.